Hello students, this video is to help review for the interim assessment number 3. It's coming up soon, so make sure you know all the topics from units 1 through 8. These are some of the examples of the pictures that we're going to be looking at. I did manage to get this into only 2 videos, which means I don't have a whole lot of time. So take a look at the first page, see if you can get the answers, and then come back to see if you got them right. In this first question, it talks about perpendicular lines form negative reciprocal slopes or have negative reciprocal slopes, which means I need to find the slope of this line. We solve for y, set it into y equals mx plus b format, or in this case, mx plus b equals y format. We get the slope of 2, which is the same as 2 over 1. We flip it and change its sign because that's what negative reciprocal slope asks us to do. That means negative 1/2. For question number 2, it asks us the distance, which is the length, which is distance formula. We use the distance formula, and it's a very straightforward formula. Yes, you should memorize this formula for the test. The length of the line segment is 17. For number 3, it tells us that AE bisects BD. It cuts BD in half, so BC and CD are congruent to each other. We don't know anything about AC and CE because it doesn't say AE is bisected, it says AE bisects. AE is the thing doing the cutting. It also says that ABC and EDC are congruent to each other. We marked that on the diagram. It's asking us to prove that these two triangles are congruent using ASA. Angle side angle is what that stands for, and that means I need another angle because I already have an angle and a side. I need the angle that's here because it's two angles, ASA, and the side between them. For number 4, it tells us that they are similar triangles, which means same shape, different proportions, proportional sides. It says 7, 4, and 9 are the sides of the triangle, 7, 4, and 9. It also tells us the longest side on a similar triangle is 36. Since it tells me that the length of the longest side of a similar triangle is 36, that means that that has to be this side here, considering that this is the longest side of the smaller triangle. So this is 9, this is 36. It's asking for the length of the shortest side, which is here, of the larger triangle. So we need to set up a proportion. In this proportion, I did long over short equals long over short. I could have done short over long equals short over long. Same thing. Cross multiply, solve, 16. For question number 5. In the diagram, it tells us that ABC and DEFG are parallel. Then it asks us to find angle ABE. So I have a couple of pieces of information, and I can use other theorems and information to get the other stuff. For example, it tells me this is 130. I can find that this is 50 using supplementary angles. It tells me that this angle is 70. So I can use the triangle sum theorem to take this angle, and this angle to add them, set them to equal to 180. And then I can use alternate interior angles to say that this angle, which is 60, is the same as this angle because of that, as I said, alternate interior angles. So it's using a lot of different theorems that we learned about in class. Take a look at the next page, pause the video, try these out, and then see if you got them right. All right. It tells us that these two triangles are drawn, and it also tells us all this information. Wow, tons of information. Well, since we know that these angles are congruent, and since we know the sides are proportional, I did 9 divided by 6 is equal to 15 divided by 10. That's the same as saying 3 divided by 2 for both of those. We can say that they are proportional. So since the sides are proportional and the angles, these two angles are congruent, we can say SAS, Similarity Postulate. SAS, Similarity. For question number 7, it's asking which expression is always equivalent to sine of x. This is just saying when x is less than 90 degrees, which means that the angles or the values of x are acute or smaller than 90. It tells us that sine of x, and it has to be equivalent to that. Well, what is equivalent to sine of x? We know that's equal to cosine of 90 minus x. Here's why. Sine of A is equal to cosine of B. That's a fact. We know that from the chapter on trigonometry. A and B in this case are going to be complementary angles, which means they add up to 90 degrees. So if A, the first angle, is x, then B, the second angle, has to be 90 minus x because these two angles have to add it together to give you 90. They're complementary. So 90 minus x is your answer here. In the diagram, it tells us that ABC and ADE are similar triangles. You can see that ADE looks like it's just a smaller version of ABC. which measurements are justified by this similarity. In other words, here we are looking for sides that are proportional. So for example, this side AD divided by this whole side AB should be equal to this side AE divided by this whole side AC. So we do all those divisions and we find one that works. 2 divided by 6 is the same as 5 divided by 15. That's equal to 1/3. For this one, number 9, you could use 2 different methods. You could use the formula method that I used here on the right-hand side, or you could use this, which is the so-called graphical method. I know that the slope of this line is 1/2. I found it by doing up and over, essentially, rise over run. I know that there are 5 slopes between these 2 points. 1, 2, 3, 4, 5. And I also know that if I'm looking to split it into the ratio of 2 to 3, that means I want 2 of those slopes on the left-hand side of the point, and 3 of those slopes on the right-hand side of the point, which means this point is the point I'm looking for, which is the point -2, -3. Well, guess what? -2, -3 is the same exact thing that I got just by doing the work in the formula. Moving on to the next page, pause the video, check these questions out, and then come back to see if you got them right. For number 10, it asks us to find the equation of a line that passes through a certain point, that passes through the point P, and it's parallel to a given line. Well, first we need to identify the slope of that given line. MN's slope is y2 minus y1, x2 minus x1. That's -2/3 when you solve it all out. You could also do up and over as I did in the previous problem, but I wanted to show this work because it's pretty necessary for you to understand how to do it both ways. So I have my slope, which is -2/3. Now I need my y-intercept. In order to get the y-intercept, I'm going to take the given point that they gave me. The line definitely passes through this point, and then substitute that x and y into the equation. Similarly, I'm substituting the slope as -2/3. I solve it and I get 5 as the y-intercept. So these two have the wrong slopes. It's 3/2 for both of those. But this one happens to have the correct slope and the correct y-intercept. So that's my answer. For question number 11, it asks if these two triangles are similar to each other. And we know that one method to prove similarity is SAS Similarity Postulate. If I know a set of angles are congruent and I know that the adjacent sides are proportional, then they are similar to each other. That's the same postulate as we used before. I can tell that the adjacent sides are proportional because 14 divided by 21 is the same as 6 divided by 9. That gives us 2 divided by 3. So since they're proportional and that angle between them is congruent, then we can say that the two triangles are similar. Here's a blast from the past. Remember how to do constructions? This asks us to construct the bisector of angle CDE. That's an angle bisector. An angle bisector steps are here. These are steps that you should know. Moving on to the next page, starting with question number 13. Pause the video, try these out, and then see if you got them right. Okay, I'm looking at a reflection over a line. Reflection is a rigid motion. It preserves distance. It keeps the measurements the same. So it's asking whether triangle, or asking you why triangle ABC is congruent to triangle A prime, B prime, C prime. Don't make the mistake that some students make of saying, well, those two triangles are not congruent, because it says explain why they are congruent. So they are congruent, just justify that answer. There are two different justifications. You can say rigid motion, and rigid motions preserve distance and angle measure, or you could say that reflection's job is to change orientation, but not its size. So image and pre-image are always going to be the same size. For question number 14, it talks about dilations. Now, this is a transformation that is not a rigid motion. Rigid motions are reflections, rotations, and translations, but dilations are not rigid motions because it's growing and shrinking, which means they obviously change size. Scale factor K is a multiplier. In other words, the distance between E and C is going to be different than the distance between E and A based on that scale factor, how far it's been stretched or shrunk. The shape is going to become smaller. We can tell that because CD is the image of AB, so CD is the new one, AB is the old one. So this is the pre-image, this is the image. In other words, we got smaller. So the scale factor has to be less than 1. So it's looking for which one of these is the scale factor of K, which means I can't use these two because they're both larger than 1. EA is a big side, BA we're not sure about. EA and EC, EA is a big measurement and the other measurement is smaller. So we can't do that either. We know, however, that EC and EA are proportional, like EC and EA. And we also know that EC is smaller than EA, so that's the answer that they are looking for. So that's my scale factor K, which is EC divided by EA. Moving on to question 15, scalene triangle, it means that all the sides are different measures and all the angles are different measures. It tells us that, it asks us which equation is always true. We're looking for the one that's always true, and we know that sine A is equal to cosine B. This is a fact that we know about right triangles, not necessary to go over. Sine A is equal to sine B, not necessarily true, not necessarily true. And then the cosine A is equal to the sine of C. We never learned that. For question 16, it's another one of those questions where you're using a lot of different formulas or theorems to try to justify your answer. But at the end of the day, we get that this angle is 50 and this angle is 50. Once I know that these two angles are 50, they're alternate interior angles. And if alternate interior angles are congruent to each other, that means the two lines are parallel. Easy peasy. Moving on to the next page. This is the page that starts with question 17. Try these out and see if you got them right. All right, it asks us which transformation gives us JKL not being congruent to JKL. Well, all of these are rigid motions except for dilation, so this is a pretty easy question. Please remember the rigid motions are reflection, rotation, translation, and dilation is not a rigid motion. Here's a pretty standard trigonometry question. It asks us the angle, it gives us the angle between the ground and an object above, which is called the angle of elevation, and it asks for the opposite. We're looking at SOHCAHTOA as our guiding factor here to try to figure out which one to use. TOA stands for tangent equals opposite over adjacent, and we know the adjacent and we want to know the opposite. So that's one we're using. We don't know hypotenuse, so we're not going to use sine or cosine. So solve this equation. This is algebra, so I'm not going to explain that part. 13.5 is our answer. For number 19, it asks which one gives us sufficient evidence that these two triangles are congruent to each other. These are the 5 methods for sufficient evidence for congruency, but only letter C is enough because only letter C gives us SSS postulate. This only gives us 2 pairs of sides, which is not enough. This is only 3 pairs of angles, which is not enough. And this is a pair of sides and a pair of angles, which is not enough. For question number 20, it asks us to use the minimum rotation formula, which is 360 over number of sides equals angle. It's another algebra problem that requires you to remember a formula. Not a big deal. Moving on to the page with question 21 on the top, please try these out and then see if you got them right by checking on the video answers. All right, we're looking for congruent figures, which, as we know, have equal measures. These congruent figures went from here to here and then from here to here, and we have to figure out what happened. Well, from here to here, we know that it's the same orientation and direction, but it's a different location. So since we changed our location, that's going to be a translation. From here to here, we did a rotation because it's got the same orientation, but the next thing that we check to see is whether it's got a different direction, which it does. So pretty easy to follow that one along. In this one, it's transforming by a dilation, which is growing and shrinking. Dilation means we're keeping the slope the same. So we look at the given line and find its slope, and then solve all the answer choices until we find the correct slope. And it happens to be choice A, luckily for us. If this was on the real regions, it's possible that the answer choice would be choice D, which means I would have to solve 1, 2, 3, 4 different linear equations until I found the parallel one, which means same slope, different y-intercepts. But that's not a big deal because you got plenty of time. Here's a situation in which you're supposed to redraw all the triangles. Please don't drive your teacher crazy. Redraw all 3 of the triangles, label them as short leg, long leg, and hypotenuse. Set up a proportion, cross multiply, and solve. There is some quadratic formula stuff here. Please be prepared for that as you learn about this in algebra. The next part asks us to find the length of HJ. HJ is here. It's a part of a right triangle, which means I'm able to use the Pythagorean theorem. A squared plus B squared equals C squared. Another algebra problem. Don't want to go over it because you're good at algebra. That's why you're here. For 24, it talks about a dilation, which means you're multiplying the sides by 3. But the only dilation that makes sense here is that you take the original side, multiply it by 3, and get B prime C prime. And then for question 25, last but not least, we're doing a translation, which is sliding. We're adding 2 to x and subtracting 1 from y, but you already did the transformation, so we have to go backwards in it. We have to undo the transformation. All right, these questions we're trying to help you with the review for the interim assessment number 3. Good luck studying.